All right, geometry. This is Unit 1, Lesson 6. We're going to talk about polygons, identifying and classifying polygons. So you can see there's a lot of different ways to classify them, and we do it usually by the number of sides. So again, some of these you're going to be familiar with. Triangle. Again, 4 is a quadrilateral, but again, things like squares and rectangles are specific types of quadrilaterals, but the generic term is quadrilateral. 5 is pentagons, hexagon. Again, 7, heptagon, octagon, nonagon, decagon. 11 actually has multiple names. For whatever reason, there are like multiple names for number 11. 12 is a dodecagon. And then as we keep going, and you can technically use this for any of them, but if we had, say, like a 20-sided polygon, we would call it a 20gon. If we had a 36-sided polygon, we would call it a 36gon. So again, 11 is a goofy one. We're just going to call it an 11gon for now, just because we don't need to get into why there's different names for 11. So again, some of these more common ones like 3, 4, 5, 6, 8, 10, 12, those ones you're going to see a lot. You should start to recognize their names. But again, I'm more worried about how you use the shapes and how you interact with them rather than necessarily memorizing. 7 is heptagon, 9 is nonagon. But again, we always like to use proper vocabulary, and it's important that when we are talking, we use the correct terminology so that people can understand what we're saying. So there's this thing called convex or concave. And so there's a couple ways to figure that out. Convex means that, we'll start with polygon. So if we look at our polygon definition, a polygon has at least 3 sides with 3 straight sides and angles. So let's add that word straight in there. At least 3 straight sides and angles. And again, if we looked at our chart, 3 is the smallest I have and that's a triangle. And we've also got these convex versus concave definitions. So concave is, if you think about that word cave, it's caving in. So it's kind of got something that's like hollowed out, or it's kind of curving inward. So curves inward, folds in on itself. And whereas convex, it kind of curves outward. So all the vertices are outside of our shape. So I'm going to add that. So again, you might have at least one vertex inside your shape for concave, whereas in convex, it's curving outward. And then again, you might have a vertex, all vertexes on the outside. So I think these ones are easiest to do when you look at an example. And so again, I'm going to extend my lines in every direction. And I can see that right here, okay, if I extend my lines, I see that they intersect at a point inside of my shape, okay? There are 2 points. So we are going to call this first one concave because, again, it's folding in on itself. Whereas again, if I look at this one and I extend my lines everywhere, I don't have any part that is folded in this example, and all my intersections are occurring on the outside of my line. So I'm going to call this convex. And again, you can tell that there's not really a part of this shape that's folded in on itself. Whereas vice versa, when we look right here, I can say, hey, this side is starting to tilt into my shape. It's starting to fold in. So I would call this one concave as well. And once again, this one, whether you consider this the original shape or whether you consider this the original shape, okay, it's going to have an extra piece. It's going to have extra stuff to it that is kind of folded. It's expanding outward, okay? It's expanding outward, so we would call this convex. So again, I think you can try to use the definitions. It does help, but really, these ones I believe are kind of like the eyeball test. I can tell that this letter A is folding in, letter B is not folding in, letter C is folding in, and then letter D is not. Now we've got this word equilateral. We've got these words equilateral, equiangular, and regular. So what do those mean? Well, we've got this word equal, okay? So equilateral means having all sides the same. And in geometry, we're going to talk a lot about equilateral triangles. So again, we've got this keyword equal. And equiangular is very, very similar, and it's having all angles the same. And then we describe a shape as being regular when it is equilateral and equiangular. So you need both, okay? You must have equilateral and equiangular for a shape to be considered regular. So if we look at this, letter A, first example, okay, I can tell by these congruence marks that all my sides are the same. So one, it's equilateral, yup. Then I can tell by these congruence marks that all of my angles are the same. So it's equiangular. That's terrible. And then if it's both of those, we can say it's regular. So I'm going to call this, let's count the sides. 1, 2, 3, 4, 5, 6. If I checked my 6, I see that I have a hexagon. So I'm going to call this a regular hexagon. Now, if I look over here, I've got some congruent statements. Again, these two angles, because they have two congruence marks, are congruent. These angles are congruent. Oops. These sides are congruent. And these sides are congruent. But not all the sides are the same. Not all the angles are the same. So it's not equilateral, not equiangular, and it is not regular. This is a parallelogram, okay? And it is just not a regular shape. By definition, we have two different sides that are the same, and we have two different angles that are the same. And again, if I look at this one, I'm not going to go through and highlight everything, but you can see, yup, I actually have all the sides, and I actually have all 90-degree angles. Therefore, equilateral and equal angular. Yup. Which makes it regular. Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, kind of an interesting way. Not always how you see a dodecagon being written, but that is what we are going to call it. A regular dodecagon. Okay. Lastly, again, using what we know about the word regular, okay, that means all sides and all angles are the same. So I can go ahead and mark up my shape. I could say, well, I know this side, this side, this side, this side, and this side are the same. So if they're the same, we can set these two things equal to each other and solve. So let's get all our like terms together. So I've got x squareds, like terms. I've got x's, like terms. And I have constants that are like terms. So first thing I'm going to do is I'm going to separate my left side and my right side. I'm going to subtract x squared, and it's going to cancel out. And then, because I like to keep my x's positive, I'm going to subtract 3x. So I'm left with 6 equals 5 minus 3 is 2x minus 8. Now I need to get rid of this subtracting 8, so I'm going to add it. I'm going to add it. 14 equals 2x. Almost done. How do you undo 2 times x? You need to divide, so x equals 7. Let's just check our work. We're going to plug it in here. We're going to plug it in here, and let's see what we get. 7 squared plus 3 times 7 plus 6. 49 plus 21 plus 6. 49 plus 21 is 70. Plus 6 is 76. So I know that this side is 76. Now I'm going to do 7 squared plus 5 times 7 minus 8. 49 plus 35 minus 8. 70, let's see here, this is 84 minus 8, and that's going to give me 76. So this side is also 76. We know we did it correctly.